Hello everyone, welcome to my YouTube channel. This is the Infinite Chemistry. In my last video, I will discuss about the particular question. This is a question. This is a compound, and this is a reagent. I will discuss in my previous video. Now, in this video, I will give a solution of the particular this reaction. So you will watch the video till the end. Okay, now in this question you will see the compound at here. In this reaction you will see the compound, and this is your compound, and in this compound having a 2,5 ring, and this is substituted at the bridge position by the methyl group, and two phenyl group also attached here, and one is here is a carbonyl compound. Okay, this is a whole molecule, and here also given in the reaction this is a LDA with THF and -78 degrees centigrade temperature, and second one is given a benzyl iodide, and third one is given at here NaHMDS 0 degree temperature, and DMF NHMDS and DMF, and this at here is also CO2. Okay, methyl and CO2. But in the reaction, first you will knowledge about the reagent, and this question is a very easy for those which have a knowledge particularly about a reagent. For example, here is a LDA given at here. So what will get given at here? What will now? This is a compound, and LDA is a, we know about that LDA is a base. What is it? LDA is a base as well as a nucleophile and reduced nucleate. We know about the nature of the LDA, but in this reaction, what will the particular approach of the LDA? For example, this is LDA, and LDA is a nucleophile as well as a base. Base also have a tendency to abstract hydrogen, and abstracting hydrogen also. What will show it here? Abstraction of hydrogen. Which hydrogen is abstracting? Which is a more acidic hydrogen, and here is a C. In this compound having there is a two hydrogen. One hydrogen is here and one hydrogen. These both hydrogen is a more acidic because of this carbonyl group. This carbonyl group is a nature is a electron withdrawing nature, and here is particularly generating a electric set. Now the question is why not LDA direct attack at this position? Why not? Because there is a hydrogen is a more acidic, and this carbonyl compound is less tendency to attack it here. This is a bulky group also, and this is not attacked directly at this carbonyl position. So we will particularly use a LDA here, and this LDA abstracting the hydrogen, abstracting from the hydrogen. Just a few minutes. Okay. Now this LDA is abstract from the hydrogen, and generating at this position is a nucleophilic site, just like that. There is a minus charge, and this Li having a positive charge. Now, as well as all the tendency to this negative charge is delocalized to this carbonyl group, and this is a non-carbon nucleophile this is a enol carbon nucleophile, and there is a enol oxygen nucleophile. Okay, there is a two form of the intermediate. Okay, particularly form it here. Now, which form is particularly taken here? See, this carbon nucleophile is a more tendency to, there is a carbon nucleophile is a more tendency to take at this position, because this is a extension of the conjugation is increased. So there is from the SN2 reaction is here. There is a SN2, particularly SN2 reaction is particularly approached here, and this iodine is a good living group, so this is removed from here. And now talking about the stereo of the compound. We will also know about the if two 5-member rings are attached to each other, and here is a junction is present, and then the approaching group having same stereo which have these particular groups. Okay, for this there is also given a stereo which have these methyl group. But it here is a first take we have not important the stereo of the particular this compound, but I will discuss it here, but it is not important. Okay, sorry, not important here. Next step, you will see. In the next step, further given a base. What is given at here? Base, and we know about that base is having a tendency to the abstract more acidic hydrogen, and this is a strong base, and the strong base have a tendency to the abstract more acidic hydrogen. Sorry, H plus. Here is H plus, and NHM case I will show that at here of the form of if you know about that. Okay, in this step, this particular reagent abstract the hydrogen. Here also one hydrogen also present here. This hydrogen here is above below the plane. This hydrogen is okay. Here is one hydrogen present, and this hydrogen is abstracted by this hydride reagent, and there is a further one carbon nucleophile generating, and this carbon nucleophile is attached to the electrophile. This is a CO2 at here. Sorry, I will not mention in this C double bond. And this carbon nucleophile, for example, this is here, and this was attached to at here, and this comes to here. Sorry. I will show it here further. In the next step, what we can do. In the next step, we will form. Okay, we will form the pH, here is pH, and here is carbon group. Now any attaching group is same stereo which having a methyl group. So incoming group also the stereo which having a particularly this methyl group CO minus double bond O, and also at here is present a benzyl group, so I will draw it here. And sorry for that, but I think you will understand with my language very well. Okay, now in this methyl group, this negative charge of this oxygen will attack this methyl group, and this iodide group will be removed from here, and the final product will be formed in this reaction is here is a benzyl group, and here is around the plane is CO2Me, and there is a stereo will be Me, and here is also Me, and pH, and here is a CO. This is the final product of the reaction. This is a note. Here is I will mention only the methyl. This is a CO2Me group right here, and this is a final product. If you like, then share and subscribe to my YouTube channel. Thank you so much for watching my YouTube channel.